And part 3, the test of statistical significance. With two proportions. So with two proportions, we are always letting the null hypothesis be that those two proportions are equal to each other. You can write that in a couple different ways. You can subtract one way or you can subtract the other way. If they were the same, when you subtract, you would get 0. And the alternative hypothesis can be the same way. You can have it greater than 0 or less than 0, or one is greater or less than the other. So two different people can do the same problem and kind of set it up and end up with different parts along the way, but you should come to the same conclusions. Anyway, when we did confidence intervals, we used the standard error that had these little p-hats all over the place, except that creates a problem for us. Because we are starting out, when we're doing trying to find a p-value, we are making the assumption that the proportions are the same. And how can we make the assumption that these guys are equal to each other and then have a standard deviation for a difference that we can't be using two different values if we're saying they're the same? So our solution is to pool. And pooled data or pooled proportion is somewhat like a average proportion out of the two. You take your count of successes for one plus the other and then divide by the total sample size, and that gives you one proportion that you're going to use for your standard error. So you thought the standard error formula was ugly before. Now it's really ugly. It's actually not that bad because both of these are going to be the same number or numbers, and you're just dividing by a different sample size. So if you really actually want to work all this out by hand, you'd have your null hypothesis, you'd pool your value, and then you calculate out your standard error, and then your z-score would be the same as it's always been. Take your value from your sample, the difference in this case, minus the null, which we say was 0, and then divided by the standard error. It's just finding all those little parts. It's a little cumbersome and stuff. But I certainly do not expect you to do this by hand. There is very little value in doing it by hand. I do expect you to do these in the calculator. So let's do an example in the calculator. In 2001, a study by the National Seat Foundation found that 39.2% of the 811 older, that is over 30, I don't really think that's older, I think that's kind of younger, reported snoring a few nights a week. However, only 26.1 of the 184 in the under 30 group reported snoring a few times a night, or a few nights a week. Does the younger group actually snore less, or is this difference likely due to random chance in sampling? That is our test of statistics. So we are going to do our null hypothesis that they are equal and our alternative hypothesis. Now they are saying, they said that the younger group actually scores less. So you might think I'm writing it backward, but the hungry alligator is eating the big number here. You do have some choices to which one you call the first one or the second one. I'm just putting the old one first because if you subtracted, you'd get a positive value, and that just makes me feel good. You should notice that if you're doing like the AP test, that whatever you write this stuff, you need to make some reference. If you say p hat 1 and p hat 2, you need to have some statement that says which of these is 1 and which one is 2. Or you can label them with names that make that clear. Anyway, this is a one-tailed test because it asks for younger scores. So, of course, we go over to stat and then arrow over to test. But before you touch your calculator, you should have in your brain that you are doing a two-proportion z-test. Z-test because you calculate a z-score. There are a whole bunch of things in this part of the calculator. Know before you pick it up what you're looking for. Don't hunt around hoping to find something. That will get you into trouble. You will frequently end up picking the wrong thing. Think about it first. Go to stat, arrow it over to test, then arrow down to two proportion test. There it is. Okay, we select our two proportion test. We were not given the counts. We were given the percent, so we have to find those percents by multiplying out. And when you do that, you get, of course, we get decimals, which is, someone rounded off somewhere along the way. But if you remember from confidence intervals, these four numbers have to be integers or whole numbers. So you have to round off. Oh, and we do need to set or choose our alternative hypothesis. We said old, which was what I put in the one place, was greater than young. So this is the number 1 is greater than the number 2. That's our hypothesis. If you forget to change to integers, you forget this step, your calculator will let you know. It will give you an error. Okay, when you hit the test, let me see here. Get rid of my picture there. If you hit the test and you hit calculate, it gives you all this wonderful information. Right off the bat is the z-test. So you know it's 3.33 standard deviations above the mean, which in this case should be 0 when the null is true. And it gives you the p-value, which it just says p equals. It's not 4.297. It's times 10 to the negative 4. So you have a few zeros there. That is a very, very small p-value. It also gives you the two proportions just in case you didn't have them to begin with, which we did in this case. And then it gives you this other p number because, of course, we need another p. What is that? That's the pooled value. Yep, see, add them together. So that's the sum of the counts of successes divided by the sample sizes, and that's what you get. You get the pooled value. So it did actually calculate out the pooled value. The sample size isn't that nice. If you hit draw, you do kind of get the main information. It will give you the p-value and the z-score. It can be very slow. It is kind of neat, though, if you actually have a p-value, it will shade in the part of the graph. Our p-value is so small that it doesn't actually show up on the graph, but it is definitely a lot slower. Okay, I want to do a second example because that one had some things we had to do, and I want to do some other interpretations. So, researchers comparing the effectiveness of two pain medications by randomly selecting from a group complaining of a certain type of joint pain. Of the 112 people that received painkiller A, 84 said it was effective. For painkiller B, 66 of the 108 says it was effective. And then we are asked to do a test of significance at alpha 5%. And if we constructed a confidence interval, would it contain 0? You are not asked to construct the confidence interval. So before we get started here, I do want to kind of look at this because one of the things about this is picking out all of this information. So I always kind of look through and think about what it is we have. We have the sample size, that's the total. And then we have the count. So that's 84 out of 112. It was not given to us in order. Whereas the second one was given to us in order, 66 of 108. So when I am doing these, I would take and I would write that down on a little piece of paper beside me before I started doing anything on the problem. So it was something like this, and I would label them. And I don't know, I'm not going to calculate the proportions because our calculator can do that just fine. So I'll just kind of write them down and then start entering. We do have our null and alternative hypothesis. They did ask just whether it was strong evidence that they were different. So we are doing a two-tailed test. And then you go to your test, you enter your numbers. So in this case, we actually knew what the count and the sample size were. So we were going to enter integers. I did select the two-tailed test. and then I hit calculate, which gives us all of our good stuff here. Our z-score, the p-value of 0.027, which is less than 5%. Then it also gives us the proportions, just in case we needed that. If we constructed a 95% interval, would it contain 0? Well, no. We just said, in part A, ignore that A, that's a B, we just said that it was significantly different from 0. And by that, we mean that it would not contain it in its interval. 0 is not one of the possible answers. So that's one of the interpretations. A few of the problems on your homework do ask you to interpret confidence intervals based on p-value and vice versa. I think both of these assignments together are kind of short. 21, when you first open it, it might look long, but the first few problems are just little quick one-pointer problems. And then you have like 3 or 4 where you actually have to go through and do a test of significance. That brings us to the end of this presentation. Do your homework, keep healthy, wash your hands, and we'll get through this thing.